Hello guys, this is GWS here for part 3 of my macro-based machine learning with video games tutorial for general purpose AI that can learn to play pretty much any game without having to program for that specific game. Um, and I've come a long way, a little bit of a long way I guess, toward the concept programming I was showing earlier. I have the basic fundamental macro structure in. I have the macros working correctly. Of course, there's no AI, there's no fitness algorithm, although that's coming very soon at this pace, at least a basic look at it. Um, and we have some great plans for the future in terms of how to optimize this for performance, where we can have a ton of different AI rules without bogging the system down. We'll be reading off of a lot of hard disk for that, and we'll be saving a lot of stuff to hard memory. However you refer to that, I'm not very technically versed, but anyhow, that's besides the point. So let me make sure we're running. We are. Anyhow, now I can finally show you a little bit more of a visual representation of what I'm talking about with the macro. So basically, this right here is just one macro, which is a little function. I'll show you it in code, but let me just show you what this looks like. As you can see, it kind of looks random, but as you can see, it's repeating itself, and this is the same macro cycling over itself. So, if I could pause this again, which I will, basically what happens is, and here's the main game loop right here, um, and this executes the current macro, the current little function, um, and here's a little keyboard command where, I'll show you that in a second. But basically, while this is running, then you just continue this. It's basic right now. I'll flesh it out a little bit more later. And then at the end here, you will get a new macro, which is right here. Right now we're just having it return a random macro, but this is going to be the meat and potatoes of the fitness, because this is going to um, this is going to take a snapshot of RAM, and it's going to look at the RAM values, and it's going to go through all the various RAM rules, and it's going to set a macro based on those rules. Basically, features in RAM that it sees, value ranges between certain addresses of RAM, whatnot. And this is what this is the execution. The execution basically, it works off of a little program counter. So, like, for example, say you're on frame 0, right? Um, like it's, well, say you have a macro that's 100 frames long, which, um, just to repeat what that definition is, like, you have your macro that starts at frame 0, and frame 0 is the first button pressed, or if there's nothing pressed, and then frame 100 is the last time that function is there, and then after frame 100, then it goes to the next macro, or repeats the same macro, which it'll go back to 0. um, and then that's what this does here. This checks the if the program counter has exceeded the maximum, resets it, and then it returns a value that we will use probably later. And then it just goes through a series of buttons and sets them to true, and then um, sets it to the joypad of the BizHawk. That's a BizHawk specific function. We can go through that library, but I'm not going to do that. And of course, here's the basic macro structure. Each macro has an array of held buttons, of course, and here's the length of n frames. Um, and one kind of cool little feature I put into is just the ability to circumvent the random ones, and you can replace it with your own button presses. And we'll see. I might show you what that looks like sometime. I might even show you this time. Not sure, but make sure voice is working. Yep, it's working. See, I don't like having to do retakes of this. And there's some globals up there. But anyhow, this is what it looks like. It's, like I said, it's random. But, it's moving a little bit forward. It's holding left and right at the same time. It's doing a little bit of bizarre things. We're going to add some functions in to maybe shortcut a little bit of the AI so it's not acting so random. But anyhow, you push a key. As you can see, it's a little bit different. It's spin jumping, but it's not doing the back and forth thing. And it's going to die right here. So, okay, so we're back in the game. So, go back to spin jumping, hit another keyboard key. And he's just going to move that step to the left and duck. But see, as you can see, the big feature is that this repeats. And, like, this looks bizarre right now. And actually, yeah, I'm going to show you what a proper macro would look like. But let's look at a couple other possibilities the computer could come up with. Just spin jumping again. And that's not good. That's not going to get you anywhere, Mario. But see, it's like I said, we can fitness out a lot of this. Ducking and jumping. Let's see, forward and back a little bit. But as I said, the key feature is that it repeats. And see, that's actually a little feature right there, is, it takes the shell, and then it throws the shell, because it's, I guess, hitting Y too. And I gotta add a little bit more stuff in, like I want to add, like, different modes for the buttons, rather than just, like, because right now the way I have it set up, let me go ahead and pause this, and I'll show you. I have it set up where each button has a start frame and an end frame. And this is all going to be based relative on the number of frames in the macro that is being sent here. That's why I have this, because that pretty much controls when a button can be pressed, when it can't be. But what needs to be done to make it a little bit easier for the AI is have like a leading press where you just have an end frame, it starts at 0, or a trailing, which is the opposite. It starts at a point and then it ends at this end frames value right here. And I think that'll make things look a little bit more authentic rather than just like random button presses, which is what we kind of want to avoid. But anyhow, now let me show you a couple more of these, and then we'll go to basically something basic you can create. Now go through the program iteration. As you can see, this is going back and forth, so let's push this and let's see what else it comes up with. And that's not the right way, Mario, but I guess you'll get there eventually. And see, what I don't understand is, like, there's a point where it'll do different inputs, which, this is not bug-free. Can you get over the chuck? Yep. Good job. This is more of something that you'd kind of expect from a good macro. Let's just see if this can get through the level. I may not even need to show mine, because this is more or less what you'd want to see. Just, just something simple, because macros, they can be complex, they can be lengthy, they can be elaborate, or it could just be a simple single press of a button. It doesn't have to be a huge thing. And as you can see, it made it through the level. And lucky for us, it's not gonna go to the next level. Okay, so let's pause this. So I don't have to show mine, but I'll go ahead and go through the code anyhow. So you can create your own macros with this. Let's see, yeah, it's up here, right here. Yeah, because you do you just create a little button array, and then you just set the buttons randomly. And what it'll do is it'll replace the macros randomly generated button list with one of your own, and you just supply an array of button presses. You just got to make sure that end frames aligns, or you might end up with an error or something, or it's going to cut off. But anyhow, that's pretty much where we're at right now. I don't think there's a lot more to talk about. So here's the future stuff that I'd like to document. Like, of course, I want to do basically the way I envision this is like we'll have some kind of initialization function where what we do is you create a file of macros, and you either put the RAM rules in the same file or maybe even a different file just to be a little more organized. You put those in text files, and then what you do is like when you're initializing, and we'll initialize with, you can initialize with quite a few, like maybe you could probably get by with 50 to 100,000 RAM rules. I don't know if this is going by stack or heap. I'm not that sure of what Lua is. I assume it'd have to go by heap because it'd be very hard for something post or non-compiled scripting language to go by a stack. So I'm assuming there's no stack limitations. So we could probably get by with about 100,000 RAM rules generated. And then at the initialization function, you generate a bunch of random macros. And then you you give each macro an initial score um, based on that particular RAM rule. Um, and what happens is when the human does the reinforcing, like first of all, what determines what macro selected is the scoring in general, and you'll have an array of scores, um, and then you, and then of course the top score is going to be the one that's selected. Um, and then what you do is, like as you reinforce it, that score can either go up or down. And if it goes down, then like maybe the RAM rule selects something different. And like how often it selects it, how many people even understand what I'm saying right now, um, is probably nobody. But the point is that I'm making the point that I'm making is that like you do everything through the hard drive, and you just check these various relationships every now and then. And we might even build an actual database for all this sometime. Who knows? Um, but anyhow, that's pretty much my future plans. This is um, going to continue on, and hopefully sometime this could be useful to somebody, if not just myself, for documentation, etc. And thank you guys for listening, and God bless.